Lesson: Auditing Black Box Models. Auditing black box models is a critical component of assessing transparency and explainability in artificial intelligence systems. As AI continues to permeate various sectors, the opacity of black box models poses significant challenges for compliance, ethics, and trustworthiness. These models, often complex and non-intuitive, can deliver highly accurate predictions but lack transparency into their decision-making processes. The need for auditing these models is imperative to ensure they adhere to ethical standards, comply with regulations, and can be trusted by stakeholders. This lesson explores actionable insights, practical tools, and frameworks that can be directly implemented to audit black box models effectively, providing professionals with the necessary skills to address real-world challenges in this domain. In auditing black box models, the first step involves understanding the importance of explainability and the potential risks associated with opaque AI systems. Explainability refers to the ability to describe a model's internal mechanics in human understandable terms, which is crucial for ensuring accountability and fairness. A lack of explainability can lead to biased outcomes, discrimination, and a loss of stakeholder trust. For instance, a study by Rudin highlights that opaque models can inadvertently perpetuate bias, emphasizing the need for transparency in decision-making processes. One of the most effective frameworks for auditing black box models is the interpretable machine learning framework. This framework enables auditors to deconstruct complex models into understandable components, providing insights into how decisions are made. A key tool within this framework is the SHAP method, which assigns an importance value to each feature in a prediction, offering a clear explanation of the model's output. By utilizing SHAP, auditors can identify which features most significantly influence the model's decisions, facilitating a more transparent assessment of its behavior. Furthermore, the LIME technique is another practical tool for auditing black box models. LIME approximates complex models with interpretable ones locally to explain individual predictions. By generating interpretable models that mimic the behavior of black box models in specific instances, LIME enables auditors to understand how certain inputs affect outputs. This tool is particularly useful for identifying potential biases or anomalies in decision-making processes, enhancing the transparency of AI systems. In addition to these tools, it is essential to implement a step-by-step approach to auditing black box models. The process begins with defining the scope and objectives of the audit. This involves identifying the specific aspects of the model that require evaluation, such as fairness, accuracy, and compliance with ethical guidelines. Once the objectives are clear, auditors should gather relevant data and metrics to assess the model's performance and impact. This data-driven approach ensures that the audit is grounded in empirical evidence, providing a robust foundation for evaluation. The next step involves deploying interpretability tools such as SHAP and LIME to analyze the model's behavior. By examining feature importance and local explanations, auditors can gain insights into the model's decision-making process, identifying potential areas of concern. For instance, if certain features disproportionately influence outcomes, it may indicate bias or unfairness, warranting further investigation. This analysis should be complemented by a thorough review of the model's training data to identify any biases or inaccuracies that may have been inadvertently introduced during development. Once the analysis is complete, auditors should document their findings and present them to relevant stakeholders. This documentation should include detailed explanations of the model's behavior, potential risks, and recommendations for improvement. By communicating the results effectively, auditors can foster transparency and accountability, ensuring that stakeholders are informed about the model's capabilities and limitations. To illustrate the effectiveness of these tools and strategies, consider the case study of a financial institution using a black box model to assess creditworthiness. The institution faced allegations of biased lending practices, prompting an audit of the model. Using SHAP, auditors identified that the model relied heavily on variables such as zip codes and loan amounts, which disproportionately affected minority applicants. By employing LIME, the audit team was able to demonstrate how specific input changes led to different credit decisions, highlighting the model's bias. As a result, the institution revised its model and incorporated fairness constraints, leading to more equitable lending practices. Statistics further underscore the importance of auditing black box models. A survey by McKinsey & Company found that only 25% of companies reported having a clear understanding of how their AI models make decisions. This lack of transparency poses significant risks, as stakeholders may lose trust in AI systems if they cannot comprehend or explain their behavior. By implementing robust auditing frameworks and tools, organizations can bridge this transparency gap, enhancing stakeholder confidence and compliance with ethical standards. In conclusion, auditing black box models is a crucial aspect of evaluating transparency and explainability in AI systems. By leveraging frameworks like interpretable machine learning and tools such as SHAP and LIME, professionals can effectively deconstruct complex models and assess their behavior. Implementing a step-by-step approach to auditing, from defining objectives to communicating findings, ensures a comprehensive evaluation of AI systems. Through real-world examples and statistics, the significance of auditing black box models becomes evident, highlighting the need for transparency and accountability in AI decision-making. By adopting these actionable insights and practical tools, professionals can enhance their proficiency in auditing black box models, ensuring that AI systems align with ethical standards and foster stakeholder trust.